Today we're starting with an arithmetic progression. It's sometimes called an arithmetic sequence. In fact, I think that's the more common language these days. In the old days, I'm pretty sure they called them progressions. But sequence, how do we spell that? Okay. Now, it's four terms. There's four terms here, and we know the first term, and we also know the difference of the squares of the third and fourth terms is this constant 1503. So we want to determine the unknown terms in the progression. That is, we want to find c sub 2, c sub 3, c sub 4. Okay, now, again, this is, I'll just say AP, arithmetic progression. What we mean by an arithmetic progression is something like this that has what they call a common difference. In other words, there's a constant value, D, called the common difference, where you add it successively. That is, it's 106 plus 1D, 106 plus 2D, 106 plus 3D. This is contrasted with a geometric sequence. Okay, so we know that our four terms can be written this way just because it is an arithmetic progression. All right, so what are we going to do now? We're going to use the given. Okay, so the given information translates to this. Okay, because this is your c sub 3 term right here, c sub 3 right here, c sub 4. And so we're squaring c sub 3, subtracting from it c sub 4 squared. Okay, and we know that that's 1503, which is a constant that's very, very useful. Now, what happens when we expand, folks? The 106 squareds go away. You know, this is in the form a plus b squared is equal to a squared plus 2ab plus b squared. So the 106 squareds go away. You get 2 times 106, which is 421d. 2d squared is 4d squared, and similarly over here. Okay? So we've gotten this far, and you see, if we can find d, we'll be done with the problem. If we can find the value of d, we can just substitute it in and we'll be finished with the problem. So we're going to try to find d right now. Now, what do we have here? It looks like this would simplify to, what do we have? Minus 5d squared. Minus 5d squared when you combine the d squared terms. And then minus 212d. All equals to 1503. All right, so you see, y'all, this is an accomplishment because we have a quadratic in the variable that we're seeking. Because once we find d, we can substitute in here and we'll know what our progression was. Okay, so another way to write this, let's see, we can write this as, if we get everything on one side, get it in quadratic form, we can write this as 5d squared minus plus 212d plus the constant equals 0. So it is a quadratic, albeit with very large values. Now, something that's quite useful here is 1503 is actually equal to 3, and this is pretty easy to figure out. You know it has to be divisible by 3 because the sum of the digits is divisible by 3. 1 plus 5 plus 3 is 9, which is divisible by 3. So 1503 is equal to 3 times 3. And then again, this is all achievable just with mental arithmetic, or you can do it. You can do this by hand, no calculator required. 167. Okay. 167, folks. And you know, I think, let's see here, 9 times 167 that ends in 3. You can check this out, but this is correct. 3 times 167. So we know, because this is an integer arithmetic. It's an integer. All of these are integers, right? And so the common difference must be an integer. We anticipate that at least, all right? At least one integer common difference, okay? So if it's going to factor, it has to look like this: 5d okay, unknown constant here. We know there has to be a plus sign here. And then you have d plus something. And this is the trial and error phase of the problem. You could use the quadratic if you want, of course. Maybe even try completing the square. But in any event, we can anticipate one of the D should be an integer in all likelihood, because it's an integer. I think it's almost forced, isn't it? Because it's an integer sequence. But anyway, if you look around here and pay some attention, let's see, what do we need here? We could try 9. This is also 9 times 167, right? This prime factorization. So if we need to get 212 in the middle. So we would have to put the 167 in this position, right, folks? Because it would combine with the D to give you 167D. And if you place the 9 here, 9 times 5 is 45, right? So 167 plus 45. 167 plus 45 is the 212 that we're looking for in the middle, right? The 212, so this is 212. And again, folks, trial and error. Again, you could have completed the square or tried the quadratic formula. Okay, but what does this tell us? This tells us that D is equal to either 167 minus 167 over 5 Okay, that's what happens when you set this factor equal to 0. When you set D plus 9 equal to 0, you get D equals -9. And we are dealing with an integer. That was given to us. That was given to us in the problem. So we can be pretty confident that D equals 9 is going to help us find our original arithmetic sequence. Now, so what we'll get right here, folks, we have the 106. Didn't change, right? It's the first term. Now, what's 106 minus 9? Is that 97? So 97 right here. Okay, 97 plus 9 is 106. Now, what happens when you subtract 9 from 97? Don't we get 88? Okay, and finally, when you subtract 9 from 88, you get 79. And y'all, you can. I think you can verify pretty quickly that 88 squared. You can if you want to off to the side, but 88 squared minus 79 squared is 1503. And that's a fairly easy verify just with the difference of two squares formula. Okay, but we'll just write it down as a fact. Okay, so y'all, this is our answer, 106. And yes, it's okay to have a decreasing arithmetic sequence. They're not very common, but our D was -9 here. And again, probably 99% of the arithmetic progressions that you see have positive common differences. I thought I'd throw you guys a curveball. All right, thank you for viewing.